Thomson was courageous enough to put a model of the atom out there for the scientific community to debate. Ernest Rutherford took advantage of the opportunity and decided he was going to test J.J. Thomson's model of the atom. He designed the gold foil experiment to test the plum pudding model. Rutherford directed a beam of alpha particles, a type of radiation with a positive charge, at a very thin piece of gold foil. What he expected was that the high-energy alpha particles would have no problem just slicing through the pudding of the atoms, kind of like throwing a baseball through a piece of tissue paper. What he observed was that his hypothesis was true most of the time, but there were these rare occurrences where there was a major deflection of these alpha particles. This next video summarizes this. Alright, let's summarize those observations and inferences from the gold foil experiment. The first observation was that most alpha particles travel through the foil undeflected. The inference from this was that the atom was mostly empty space. There is no positively charged pudding. Secondly, some alpha particles are deflected at angles. What this meant was that the positively charged alpha particles were encountering another positively charged object that would cause them to be deflected. That is the nucleus. Finally, some alpha particles were deflected straight back. This meant that whatever the alpha particles were encountering had to be extremely massive. So the inference here is that the nucleus contains most of the mass of the atom. Rutherford's contributions included discovering alpha, beta, and gamma radiation. He is credited with discovering the nucleus, and he produced a new model based on his observations from his gold foil experiment. Rutherford's model is known as the planetary model. Okay, what does it look like? Rutherford's model is probably what you picture in your brain when you envision an atom. There is a massive positively charged nucleus in the center of the atom, and the electrons orbit the nucleus. The amounts of positive and negative charge are equal, and electrons are held in orbit due to an electrical attraction to the nucleus. Overall, the atom is mostly empty space. Rutherford's limitations include a lack of evidence of electrons actually orbiting the nucleus. Once again, he is exercising his courageous creativity. He is taking a risk putting his ideas out there. He did not explain the composition of the nucleus or define the orbits of the electrons. And then the biggest limitation is the fact that the electrons are moving charges. Moving charges create magnetic fields and give off energy in the form of electromagnetic radiation. If electrons are constantly giving off energy, then they should eventually run out of energy and crash into the nucleus. And then kaboom! This simply does not happen. As Cy would say, that's crazy, Jack.